So who is there today? So we have, I'm going from A to Z. We have Alan Nash here. He's a first timer and he is listening in whether we do good things or not. Then we have Alex. Alex is someone who is onboarding today. Then there's Alexei, where we had a discussion right now with Chris Lito. Chris Lito, who is just showing us his chair. Then there's Christian. Then there is Lionel, already onboarded for the AllSky team. And then there's Mike, an old AllSky team member. Then there's me. And then there's Tommy. Welcome, Tommy. And welcome, Rebecca. Welcome, you're from San Francisco. I don't know, from California, I assume. So you've better weather than we have. I'm freezing here. Then there's Isaac. Welcome to Yannick. Yannick, we are onboarding today with you two. And there's Wolfgang from Germany as well. Wolfgang, we have to discuss some topics, let's say, in the onboarding process if you want to. So, guys, please turn on your videos if possible. Otherwise, it's hard to manage and to know who is talking. Okay? I don't know whether it's listening to me or they are still on the toilet. Anyhow, okay. Christian, we have 3 topics today: the climate control topic, the AllSkyCam topics, machine learning topics, and for the last point, sorry, I have to look it up. Yeah, the GUI team. Rebecca is there too. Rebecca, do you listen? Do you hear us? Do you hear me? Hello, hello. So, guys, can you please turn on your videos and your microphones? Otherwise, this is no discussion, but more a presentation. So, Rebecca, do you hear me? Hello? Okay. Can anyone who hears me tell me that he hears me?
I can hear
Who is I?
you. I hear you.
Chris, you're okay. Christian, you're okay too, right?
Yeah.
So, and Alex, Brad, Lionel, Mike, Beeks, Isaac, Yannick, and Wolfgang, do you hear me? Or are you still on the toilet? Okay. Yeah, okay. It starts difficult. Maybe Christian, let's start with us. We were talking today about the idea to enhance the buffer for the Nano, right?
Yeah.
My point is, would that be really from performance wise spoken be feasible? I mean, would it work like having a real buffer enhancement on the Nano if we use a Pi, for example?
First of all, the Pi 4 would be the buffer, and we would just transfer the material that's in the memory. And for the memory, we can have a speed up to 60 megasamples per second, which makes a transfer time of 3 to 5 nanoseconds. And yes, this could be a speed up, a performance a gain in performance, and then we use the Nano just as some kind of graphic card for the Pi instead. And yes, therefore we can transfer the data that is stored in the memory.
So the
But
idea
we have
is,
to look into it. There are some benchmarks about memory transfer via SPA and DMA, and they look very good. So we have to try that.
so the idea is to hook a camera directly on a Pi and using the Pi only as a video buffer that
Yes.
is directly via DMA connected to the Nano. So by that enhancing or enlarging, increasing the buffer size of the Nano.
Yes.
Yes, okay. Okay. And you're gonna test this now. You're going to test this in the
Yes.
next couple of days. Okay, good stuff.
Yeah. But first things first, I'm going to set up the INDI protocol and get the camera running without any GUI on that, because we do not need any GUI on the Pi for the INDI stuff. And first thing is to get a stream up and running, so we can test the connection and the data transfer later.
So does that mean that the INDI lib, which is actually the hardware layer, to be used on the Pi, or is the Pi just an intermediate that takes the stream that's coming in and buffering it?
No, it will run on the Pi, because this is tested. This is working in astronomy for the last 23 years now. And okay, you do not have to run it on a Pi. You can run it on any computer as well. But with a Pi, I'm testing it right now for the last 2 years, and I made good progress with it. Even 16K cameras we use in astronomy, that runs fine, especially for videos. And
Okay.
you can record it via Wi-Fi networks or large area networks, and with no time lapse or with no time delay.
Yeah, okay, but this is of no use case for us in this way.
No, but you can record it on an SD card as well.
Yeah.
But this time we tried to stream it via DMA to another, let's say, to the Jetson Nano. And if that works fine, then we have got a hardware video buffer just with a Pi.
Would that also help in, because we would have a split process on the Nano where the raw material at the moment when an event is detected will also be stored to the file system. Would that be a task that the Pi could then do? Because it's more or less copying from left to right.
Yeah, the recording can be done by the Pi too. It can be it can live stream and record at the same time, because the Pi has got multiple CPU cores.
Now, my question was, would that help the Nano, the performance of the
Yes.
Nano to be increased? Okay.
Yes, because
Gotcha.
the Nano just has to do the ML stuff and is not occupied with streaming or recording.
Okay, good idea. Would it also be applicable for the PT set? Because there's, or do you say no, Nano is no way on the PT set?
Yes, it would be applicable for the PTZ too.
Okay.
Using the same stuff on the Jetson Master or the Jetson PTZ, I would recommend that.
Makes
Because
sense.
then we do just need one and the same programming, and we do not have to set up different software.
Which would make the system even more cost efficient, because if we do not need an AGX on the PT set, and the Nano would be sufficient, because all the controlling is done by the external drivers and the teensy boards anyways. So there's only image processing done on the Nano. So if the Pi helps here, we can keep it cheap.
Yes.
Okay, good stuff.
That was the point, using what we have on hand. And since the HGX is short on the supplies and will cost about $1,500, at the moment and can't be delivered, I don't see any other possible choice than doing that this way.
Yeah.
And Brett, you have got a question?
Brett, are you there?
Yeah. I think your question was about the MCP. Yes. With bringing the video buffer to the Pi, it can do, because the MCP is very small. It's just a caller of other tasks. And this can run on the CPU of the Nano, and the ML stuff can run on the GPU. And so it is split. And if some help is needed, the Pi can do some other parts of it. Yeah, Mike?
So I was just going to mention something in that with the sample tracker, not all of the OpenCV methods that we use is implemented on.
Because
have you ever tried to record the ISS on a smartphone? Try that. You won't succeed.
Yeah.
Because the resolution of the optics is too small.
Yeah, this is problem.
Well, that's why, can I cut in real fast to, I guess, Alan and Alexei, we had this talk 2 weeks ago. So basically, the Meteor system that I was talking to Alan about, it does post-processing. They use 7 cameras, but they're smaller cameras. So they're able to cover, the whole sky, essentially. But, so this project, why it's different is Christian is basically saying that it's better to go with one camera that has a higher resolution, and then apply the software onto that one input of higher resolution optically than it is to use 7 lower optical cameras, because you'll never detect it. So that's why they're going with one more expensive fisheye lens that covers the whole. Yeah, it brings in, it's more optically strong, so that now when you apply the AI processing, you're able to detect things.
Right.
Yeah.
I get that. I just want to make a quick point. With the fisheye lens, basically, it has different resolutions across the lens itself, right? So the sides don't have as good of resolution as the very center. So that might help with the conversation you guys were having earlier, because different parts of the fisheye have different resolutions.
Yes, and you have to take the atmospheric stuff into account, especially the seeing. The more you go down to the horizon, the more air mass you get, and below 30 degrees of height, you can't do any photometrics or astrometrics, so you can't determine where the object is because of the refraction.
Well,
so.
What I was getting at is
additionally.
Basically, he was saying you won't get the 1 pixel, but that's if you uniformly spread the view over the 180 degrees. Is that correct in thinking like that? But because it's not uniformly spread over 180 degrees, it's fuzzier on the sides, more focused in the middle. So in the dead center, you should be able to get the International Space Station.
Yes.
Yeah, but the resolution of the optic and of the sensor has to match. So it doesn't make sense to have an optical resolution which is much better than the resolution of the sensor.
Yeah, you get oversampling and undersampling, of course.
Guys, if you look at my share screen,
what you mean by oversampling and undersampling?
If the camera can resolute much more than your optics can, you've got undersampling, and if the optics can show more or resolute more than the camera can, you've got the other way around. You've got undersampling if the camera is not as good as the optics, and you've got oversampling if the camera can resolute much more than the optics can.
So must be balance between optics and electronics.
Yeah.
And the Nyquist-Shannon criterion gives you exactly that.
Christian, I shared the screen for the
Yeah.
Raleigh and the criteria. You
Yeah,
want to
it's-
explain?
Sorry. Yeah, it's been an hour and a half, so I guess after this, Alan, I'll give you a chance to leave and come back next week, or I'd rather have you come every week rather than we kill you one Sunday. Sheila is like, no, you can't come back, So after this, I'll clear you off, I guess. That's cool.
Okay.
I wonder if we're getting a bit lost in the weeds here at the moment. I think I think we all agree we need a sort of a specific camera that can capture certain images, and then we need to process those images to try and you know what I mean. I just don't want to get too kind of lost in the detail, really.
Well, I think the key is just to align, because they're starting at the beginning here, just to make it all balanced. I think that's the big key that you guys already mentioned. The optics should balance to the sensor, and it should balance to the software designers. Because I think one key thing is you're starting right here, and that's the big difference between SkyHub, from what I understand, SkyHub and Sky360, is you are designing with the hardware and the software from the ground up in mind.
Right.
And I think it seemed like it was lopsided, which falls apart, right? If your hardware can do one thing, but your software can't, it's never going to work.
Right.
So I think it just all needs to be balanced. Simple is probably better to go to the coding as well. So that's why.
Yeah. And Wolfgang, I want to tell you, we should do a meeting if you want to, and we will explain what we think is the right criteria and parameters for our fisheye cam. Because as Mike said, it goes too deep at that moment here. So we can talk at a later time.
We can also discuss it in the Discord.
Yeah, good point.
Maybe we should make a sub an area for optics maybe also.
Okay.
So that I think in hardware, if we discuss it in hardware, maybe it's getting lost.
Yeah, let's talk about this. I will certainly pick this up with you.
Mm.
Okay. So next point, Christian, you want to go to climate control, or you want to go to machine learning and motion detection?
I can see Christian.
Yeah, I'm here, but I turned off the light because the battery died from my light, and I will have to go on without camera because
the guys. My next thing about climate control.
Okay.
So I'm gonna testing this week the Peltier element, only the Peltier element, because I was thinking we was dealing with something. For example, the Richard and Brad was doing the stuff like that. But I'm going to focus only on delta T.
Mm-hmm.
How much maximum difference I can have from cold side to hot side, So this is I will post on a climate control, my findings. So this is kind of driving the Peltier element is the way we driving the Peltier element is very important.
Mm-hmm.
So it's not about pulse width modulation, but they Texas Instrument find out, which is I post. I don't know. I didn't post on right here about the way you driving the Peltier element. So I'm gonna post my findings this weekend. So
yeah,
this is kind of important.
Yeah. So what I want to ask you, Bojan, is what for are you using the aluminum blocks?
2 aluminum blocks just for testing. For example, I don't wanna, I use this, let's say, 1 inch by 1 inch by 1 inch blocks, and on a both sides, and without heatsink, fan, and stuff like that, just to test how can I, because let's say you have on a Peltier element plus and minus, right? So one side is hot, one cold, but you can switch sides, and then you can switch which side is cold and hot. So I'm going to use these two blocks just to test it and attach the this is like a LM35. This is like a device which is measuring the temperature. So just to test how can we use one Peltier element for heating and cold.
Yeah, and he's got an identical thing on both sides, so he can flip back and forth, and you have a fixed control.
Yeah. So that's why I'm using two blocks, aluminum blocks, to check it out what's going on without
Different size heat
like
sinks.
a Richard.
Yeah.
So just the core of our so let me do this, and I will post my.
He's doing what I should have done and eliminate covariates, but I didn't do that because I'm not a good scientist.
You know what is the problem for me is you building the system without do the research in a how can I say, the Peltier element is the core of our system, cooling or heating system,
Yeah.
and you don't.
I see. So
and then
you're looking for the
you doing
okay.
You doing research, but you don't know how can you drive this Peltier element. So this is very important to have first, how can you drive this element? Because this Peltier element, whatever part number is, you need to drive somehow. So we have 12 volts power supply from the box, and we need to figure out how can we drive first, and then data we have. I need to have this weekend actually to figure out how can we drive. Then we can go further.
Bojan, can you make a correlation diagram with your setup to say, okay, with what voltage I achieve what delta T?
I can I don't have right now, but I have a TI, the Texas Instrument data.
Are you going to do? You're going to go for current though, at first, yes?
A constant current, because Texas Instrument has application note about driving the Peltier element.
Yeah. Okay.
So I'm gonna apply this application note to our chip on a Monday. I think I will have on a Monday from Amazon, and I'm gonna apply this constant current driver. There. Give me a minute. So this is actually very important to follow. For example, Texas Instrument is serious company, so we're gonna follow this kind of application research stuff like that,
Yeah.
So let me do this in the next 2-3 days. I will post on a UAP track form.
Okay. What I would be interested, Bojan, is if you can draw a diagram of input voltage, output delta T. so that we know how responsive the system will be.
This is my target.
Okay.
Number one, we have a reference. So you got start when you do something like that. We have 12 volts power from our power supply, right? So how much we can have, what we can have from actual unit? How much cold or hot we can have for actual unit?
Yeah.
So, but I'm not. What I am using I'm using the aluminum, the sticks or whatever, just to see what's going on,
Okay.
to measure what's going on,
Yeah. Okay.
So this is all.
Perfect. Got that. So we expect this in the coming days, your data.
Yes.
Okay.
Yes, sir. Yes, sir.
Good
Yes,
stuff. Hey, Brad, talking about the climate control and your setup, you said that you are now know what kind of heat sinks you are going to use for the inside and outside. Did I get that right?
Look. Richard, stop right there. Don't. Let me tell you something. See what kind of data I will have from my little research,
Okay.
So from there we can go with heat sinks and stuff like that.
Okay, got it. Yeah, perfect.
That's what
Yeah,
I'm talking about.
Let's keep it that way.
I'm worried about it.
Yeah, okay, understood. Let's keep it that way. All right.
What Brett was up to, Brett and me, we talked about the heatsink stuff, and we came up with another solution that we just use the Peltier elements for cooling and not for heating.
Yes.
No. I'm sorry, Christian. This is wrong. My problem is the Peltier element has one side heating, one side cooling. But
of course, yes.
You switch polarity, and then you can have both. You can switch heating and cooling. So my problem is, how can we will be using ordinary, the like a, let's say, CPU cooling stuff.
Yeah.
My problem is to use two same blocks, aluminum blocks, on a Peltier element, and then switching the polarity, and we can have on a both side cooling and heating. Now, my problem. Hold on. My problem is, how can we use this kind of? This is nice element. I mean, Peltier element is kind of cute.
Boyan, come to the point.
Stuff. So how can we use in our design to heating and so both sides can be on a Peltier element, can be heating and cooling. So how can we use that in our design to manage the constant temperature in our box?
Okay.
This is.
Yeah, thank you, Boyan.
Yeah.
Christian, you wanted to mention something different, I assume.
Yeah. Brett and I were talking about about another solution where one uses the Peltier element only for cooling and resistance wires for heating.
Okay.
But in very selected spots.
Okay.
Yes.
Like a hair blower.
But go on, Brett.
We've had this idea before, because except for we would still use. Maybe we should clarify this. We would still need to use the Peltier's heating capabilities, but only in extreme circumstances. Say Alaska, when it's minus 40 degrees Fahrenheit and Celsius, because those are the same things, and we can all agree. You start to have problems with the teensy around -10, that kind of thing. So, I mean, extreme cases, the electronics of the enclosure are not going to be able to keep it warm enough. We would kick on the heating mode, and then, of course, the Peltiers, being Peltiers, would just warm it up to an insane temperature, and we'd be fine. No matter what we do, we can produce enough heat. What Christian's point is, and what we kind of came to was, we were probably being a little too liberal with our estimates of we're keeping the internal temperature of the entire enclosure too cold, and it was 233 some odd watts we were going to have to dissipate on a hot day.
Mm-hmm.
That's kind of a tall order, so we've whittled that down to now I think we're like 146 watts, keeping the temperature of the enclosure around, what do we say, Christian, 25 to 30
Mm-hmm.
was the range.
Mm-hmm.
A lot easier target to hit, and so it's just keeping in terms of like the cooling, just keeping things generally cool, so it doesn't get too hot, and then keeping the dew off of the optics both inside and outside the enclosure. That's kind of the key part for the heating side most of the time. So that's most easily accomplished with a small targeted, heating element that consumes almost no power and it can be controlled easily.
When you
As opposed
say
to like heating the whole thing up.
when you say
Christian,
targeted,
I have one question. I have a question because fisheye camera, fisheye optic is outside, right?
Currently, yeah.
No, it's as
Under a dome.
it's under a dome, and that dome must be kept dew free.
I think
but
Boyan.
but fisheye camera is outside, right? I mean optic.
No, inside.
Right?
No,
Under a dome,
it's
inside.
under a dome.
Yes, but if we're using the Dahua, it has its own case, so it is kind of outside of our system in that regard. If we were using other optics,
Okay, just a cover.
Yeah,
Yeah.
that's true for the old Tahua. We are now talking not about the old Tahua security cams because we do not use them in the future. They are a good basic to start with, but our goal is something different, where we have a sensor that is underneath a dome. So in that way, it is part of the enclosure.
Okay.
So, Brad, you said something that confused me. Do you mean that you want to kind of a hair blower heating grid inside the climate control device or inside the enclosure?
No, so no blowing at all. It's just a small. They use them in astronomy. A small heater for the PTZ optics to keep dew from
Okay.
forming.
I see. Okay. Locally, only
It's
at the optics.
it's made
Okay.
it's made of resistor wires that just are fitted to 12 volts and with some kind of potentiometer to control the heat outcome. It's pretty effective, and you do not need any PID regulator or pulse width modulation to keep it at a certain heat. It's pretty easy and used for dew heaters in astronomy for, I think, 25 or 30 years now.
Okay, so that actually means we stay with our project now, with our goal to use the Peltiers for heating and cooling, but you need additional heating wires around the optics. Did I get that right?
To
You know,
keep the domes.
Christian, pardon me?
let me guys, let me do research next 2-3 days.
Yeah, Boyan,
about Peltier.
Boyan, that's the Peltier thing. That's already checked. My question is now for Christian. Is this the same as we are spoken last week? So we use the Peltiers as we mentioned for heating and cooling, but you need additional wires for the optics.
Yes, Brett and me discussed that, and it would be nice to add those resistor wires just for taking care of the dew on the domes.
Okay, so this is an additional. It's not separation of. So not exchange.
And it does take complexity.
Sorry, I don't understand these resistor wires. What's going on about that?
If you put some current through it, it warms up.
I know that. Why?
Yeah, and it is enough to keep the dew caps dry, and the domes too.
just locally at the optics.
Yeah.
Nothing to do with the climate control device.
Nope.
Okay.
The climate control device is just operating at extremes as opposed to having to control everything all the time. It simplifies things.
Yeah.
From a control perspective.
Okay.
Also,
Oh
if we were
my
to
goodness, I don't know
Bojan,
why you're doing
has
that.
nothing to do with the climate control device. You do not have to control this. Okay? So what Brad and Christian were now talking about is only kind of a heating mechanism for the optics, at the optics.
You know what? I have no clue about optics, but I know something about electronics. So, you know, something.
Don't worry.
Huh?
Bojan, don't bother. We were talking about dividing the cooling part and the heating part, and then we said, okay, no, we are going to leave it like that. But what we have to take care of is the dew that comes from the outside to the domes. And therefore, we talked about
You're talking about domes. This is PTZ head, right?
and the dome above the AllSkyCam, both. But it has nothing to do with the weather inside the enclosure. It's just about keeping the domes free of the dew from outside. This was just talking about ideas how we can take care of. It was nothing rock solid at the moment.
Okay. I'd say we switch over to the next step. AllSkyCam material, machine learning, motion detection, and so forth. As I've seen, Paul is here too. Paul, can you hear us? Paul?
Hey guys.
Yeah,
Yep.
there you are.
Hey
Very
Derek.
good. So maybe Mike, you can give us a short update. What happened in the last 2 weeks? Because Paul, I think, is not maybe at the latest.
No, that's fine. Yeah, so I'm still processing videos. Nothing terribly interesting to add other than that. Really, it's just it's taking a bit of time. And then for every folder I've got 1,000 videos to basically manually look through, and just kind of get rid of the junk. And once I'm done with that, I'm gonna see if I can upload the results for you guys somewhere. Once that's done, I'm then gonna look at the VPI, stuff. Essentially, so I can't look at the VPI stuff at the moment because I can't pass my graphics card through to my VM. So I've got to do that sort of stuff local to my machine, and I don't want to go installing that right now until I'm finished processing the videos, because I really don't want to do that again. So yeah, that's kind of where I'm at, really.
Okay. You gave me some video clips that I put into edited to a video reel. You can see it on YouTube. I posted it in channel chat, I think, or machine learning channel, and it shows pretty good the current status where you are with motion detection. I have one question there. Of all the videos you processed, at least of those videos you processed and showed us, let's say several seconds after an object came into the view, the motion detection started tracking. What do you think why is this time delay? Why is it so big?
Okay, so I can probably explain that. So essentially what we do is when we pick up motion and for a specific object, we try and we try and determine whether it's a good target to track, and in order to do that, we have to process a couple of frames before we kind of decide it's a good trackable target. And it's the delay that you are seeing is the time we're taking to try and decide whether it's a good object to track. So that's why you're seeing that delay. There is also, I've included some additional logic to also try and determine when it's time to expire tracking an object. And the reason I do that is because sometimes the tracker gets a little bit confused in that it tracks something and then it latches onto something else, which doesn't, like a bit of a cloud that is stationary. And once it's latched onto a little bit of cloud, for example, that is stationary, it'll keep on tracking that until that cloud disappears or changes. So I've got some other logic in place now where if the object is stationary for a period of time, it will then stop tracking. If it moves, it will then track it again. The reason for this is so the most compute intensive task that we currently do is to try and track an object. So if we get to a point where we're tracking a phantom object, in my opinion, it interrupts the potential of tracking a good object, if that makes any sense. So I have seen, and I mean I don't have an example right in front of me at the moment, but I have seen examples where it latches onto a bit of cloud and it will try and track that bit of cloud for tens of minutes, and that really slows the whole process down quite a bit. A lot of this is also geared to try and ensure that we process at a reasonable frame rate. So because tracking is the most resource intensive task that we do, my opinion is, or my view is, that they really need to be good objects, or we need to kind of ensure that we are tracking something that's worth tracking versus the tracker latching onto a bit of cloud and just staying in one position for 10 minutes. So there's logic in place to try and accommodate that. That logic is driven by a couple of parameters. Those parameters are currently hard coded, but the first thing I want to do once I've done all this video processing is I'm gonna move that out so that it can be driven by the configuration file, versus hard coded in the code. But essentially that is why it's a bit of a delicate balance. It's kind of a bit of a delicate balance really between so tweaking these parameters so that they actually try and track a good object, and then keep on tracking that object, versus tracking phantom objects and latching onto things that aren't actually there and all this sort of stuff. So it's not an exact science, unfortunately. I've tried to tweak it as best I can based on how quick a plane flies across the screen, that sort of thing. One of the reasons why I've got so many videos to go through at the moment is because some of the video segments it's tracking a plane across the screen, and in doing so the plane's not going fast enough, so it's actually generating 3 or 4 video segments with portions of the plane being tracked.
Okay.
So it's stuff like that. So it's Yeah, I think it's necessary in order to ensure that we are tracking good objects or good targets. But I can't. I don't. There's no way for me to try and. So when it's tracking something, at the point of tracking it, obviously it doesn't know whether it's a plane or a bird or a UAP. You know, it's not going to know that. All we can do is try and feed it some sort of list of options to say if it moves at this speed, then it's probably a good target. If it really goes very slowly, then track it as and when it moves. That sort of thing. Sorry, that's a very long-winded explanation to your question. I hope that answers it.
No, absolutely does.
Sorry, Rich.
Maybe I can.
Yeah, go ahead.
Yeah, man, I have to punch out. Like I said, I'm single man with the kids, and I don't know what they're doing upstairs. They're destroying stuff. So thanks for everything.
Yeah, all right.
Chris.
Thanks for having you.
I hope
and
I'm helping, man, and not messing things up. Just tell me. So.
And you do an update in the coming days, weeks, yeah, on your.
Yeah, definitely. I'll talk with Alex here a little bit afterwards, Alexei, and then we'll organize. And I'll let you know in this coming week. Yeah, the point is to try and again help, not interfere, and whatever you guys can add to that is great.
Yeah, perfect.
Cool. All right.
Good.
I'll see you guys.
See you guys.
Ciao.
Thank you.
Ciao. So I have a question to you, Mike and Paul. From my point of view, but I can be completely wrong here. I think a method like motion detection is the first step to recognize whether there's something significant changed in the sky. Would it make sense to make a how do you say this in English? A cutout, a cropped, very small cropped image. Let's say maybe the event is a plane, and let's say we take 100 by 100 pixels around that plane and throw this into a neural network, and in parallel, so that the motion detection just keeps the vector of that event, but during the time of tracking in parallel, the neural network can say, this can be a bird or can be a plane. Would that kind of a parallel method be feasible? What's your opinion on that?
Yeah, so I think that is an interesting option. And I think if I had unlimited processing power, that's probably how I'd approach it. I'd use a machine learning algorithm to detect the motion itself, and then a different machine learning algorithm, a classifier, to decide which object it was, and you'd get a percentage of each of the things that it knew about. You know, percentage that this is a plane, percentage that this is a bird. And then maybe you'd say for everything that I can't identify, that would be the interesting stuff, right? But that means running 2 ML algorithms. Now, we're really struggling to get one going.
Not necessarily.
On this sort of hardware.
Yeah.
So, sorry.
So I've been getting started on the project, and so out of the annotations that the simple tracker produces, I've been doing some feature engineering, and I extracted the azimuth, so the direction of the vector, and the azimuth, the distance, so from first frame to last frame. So I know it lacks frames in between, but that's one parameter that I deduce from the annotations of the simple tracker. And then the box area. I don't know if that makes sense or not, but I had the info, so I deduced that. and I put all this into a k-means classifier. And so that I thought that given enough data, I would be able to make a differentiation between a plane and a bird, because they would not have the same bounded box area, and they would not have the same speed, and distance might not be so discriminant. But anyway, so that's the first thing I tried. It was before I saw your post on the LSTM algorithm, so I'm going to try that too. But I think that we cannot do image detection on the bounded box area because the ISS it's 2x2, so it's too small. So I think that we have to make a first classifying layer on just the data that we have. So what I had was the area, distance, and angle, so azimuth. And speed, I don't have that yet, but I was planning to deducing speed.
I
About
have
the
question.
ISS, let me cut in there. About the ISS, since we have got the two line elements, we can calculate the ephemerides of the ISS. So we exactly know when the ISS will appear and where. And this gives us a good possibility of catching it. So
No,
if we've got that, if we detect an object that has got 1 pixel and is going in that with that speed from the west to the east, we can compare it with the ephemerides of the ISS and therefore catch it. So yeah,
Christian,
for all those small objects about 1 pixel in size, we have got a data bank to look into such movements.
Yeah, but these are not
Christian,
subject of the machine learning. Okay, Bojan, go ahead.
Christian, I have a question. I have question for you. So why we are focusing on ISS? Why we are not focusing on little closer object so
Now,
we can have
Bojan,
more quality?
Bojan, it's not a focus. We're not focusing on the ISS. The ISS is only a benchmark so that we can develop the hard and the software to the point that we say, okay, we can detect the ISS because we knew the ephemerides, or how it's called. We know where it should be, and there, oh, there's this yellow light. That's the ISS, and then we can see the PT set, and then we track it. So this is only for the benchmark. It's not the goal of the system. The goal of the system is still UAP tracking. So we want to know whether whatever comes in, we find it, recognize it with certain probability, and then track it. So that's all.
Can we have some closest benchmark?
No, the benchmark is okay. I wouldn't derive from that. But the goal of the system is something different. The benchmark is only to have a goal, not for what the I say this in English. We develop with a goal to be able to fulfill the benchmark. Okay? But the real goal for the system is something different. That's only for specs, let's say, okay? So we don't need another benchmark.
Okay, if we can track the ISS, then anything as light, as far away, and as huge can be detected. So a 747 at, let's say, 150 kilometers away has a certain angular size. And in daylight, it is a more or less black or grayish amount of pixels. And we can track that too. But let's say a 747 500 kilometers away and let's say 6 degrees above the horizon can't be tracked. And that's why we chose the ISS, because in any case, it is in the night very, very bright and has a defined path.
Okay. Mike?
So that's why we choose that.
Yeah.
Okay.
Mike?
Hey
want to
guys,
say something?
can we?
Excuse me, Paul. Mike wanted to say something.
What I was just going to, sorry, what I was going to say is some of the videos I've been looking at is rain, and if you're going to try and track something that's 1 pixel in size, so we might have to think about what we do with rain. If it rains, then we don't track or something like that, because I'll show you some videos of rain, and all they are dots that kind of move, you know. So it becomes tricky with.
I want to clarify the benchmark again. It is not meant as a benchmark for the machine learning for the motion detection. The benchmark is only for defining the hardware, what kind of sensors, what kind of optics, and so forth, so that it's all on the same page, let's say. All systems like the Fisheye and the PTZ, and even in the future with the passive radar, it's all defined on the benchmark. It can fulfill the benchmark rule, okay? But it is not necessarily that the motion detection set should be able to find 1 pixel movements in the air and say, oh, what is this? What is this? You would find millions of it. That's not the goal. And what Christian meant with the ephemeridis is we know at what point in time where the ISS will be. So it would be from the software side very easy to say, is there something in the Fisheye material at that particular azimuth and direction point where it should be? And if, then the benchmark is fulfilled, check mark, that's all.
Yeah.
Paul, you wanted to say something?
So going sort of zooming out a little bit here.
Yeah.
I think what we're trying to achieve here is some algorithm where it meets certain requirements. I'm not sure we've agreed on what those requirements are yet. So that would be a good start for us. And the sort of thing I'm thinking about is the precision, recall, and frame rate. Okay? And if we use those as our high level for this is what we need to build, then people can work independently towards those requirements.
Right.
One of the things I'd like to do is add precision recall to the background subtraction so that we can understand how that compares to our machine learning efforts. Because at the moment, we don't really understand how good it is. Because we've got nothing that's actually testing it. Right? So if we put this framework in place where we can compare various algorithms, and then as we go to like production, if you like, we choose the best algorithm based on these requirements. Does that make sense?
Absolutely.
You know, we could go to production with the background subtraction algorithm if it is the best one at the time. Right? It may only be doing.
Look, the bottom line. We need good picture of UFO object, right? This is the bottom line, right?
Right.
Okay.
So I mean,
don't know what you mean, Bojan, but yes, you're right. So
I mean, no. I mean, we need good picture.
Yeah, of course.
We need good picture of UAP or UFO or whatever. Good picture, because right now we don't have any good video recordings or photo recordings on UFOs. This is our problem. This is our problem.
I'm talking about the fisheye camera and the associated software. Its job is to.
Bojan, please.
It does matter.
Bojan,
it
please
does matter
let him talk.
What we're trying to do is find something that we can hand off to the PTZ, and then that will take a higher resolution image.
Exactly.
Right? The requirements for the different components of the system are completely different.
Right.
Yeah. Something like that.
Yeah, exactly. So
correct. Excellent.
What I want to say, Paul, is at the moment we are still in a very early stage. We don't have a playbook, so that's very easily to code that from A to Z. We are in a phase where we still try and research and develop things and throw away. So we are in a very early, scouting time where we just sort out what works, what does not work for us. That's why your expectation that we have a playbook that is from A to Z, everything is in detail, is something that we have to develop along that road. And Christian is already filling up the GitHub, the ClickUp, where where he puts in things we already know that have to be developed like that, like let's say tickets or list points. But let's say the discussion we are now leading about machine learning and the material of the fisheye, you're quite right that this is a very processor consuming task to analyze a frame inside a video. But I'm also sure that this is true, that if you take a smaller part of that picture, of that frame, and throw it onto a neural network that is trained for smaller pictures and not the 2880 by 2880, but for smaller ones, for example, that this would be much more performance-wise, much a better way performance-wise. So I think the combination of a motion detection, just detecting there is something significant in movement, then taking out a snapshot, a cropped part, let's say 100 by 100 pixels, or let's define that, and throw this in parallel into a neural network, while in parallel that motion detection is still tracking those tiny little events without knowing what it is. And then the machine learning, the neural network, after it decided whether it is a bird or a plane, then goes back and say, so I'm sure I can give it with a higher probability what it is. So my point is not to have two machine learning networks running at the same time, but only one on a smaller material, and on the other side, a motion detection that generates that small material. What do you think? Is that feasible, or is it just crazy idea?
So, no, I think that's an interesting option. And what I'm trying to do is frame it within the overall requirements for whatever it is, whether you use a single machine learning algorithm, whether you use motion detection and a machine learning algorithm, whether you use a machine learning algorithm does like both of them and tracking, right? Mm-hmm. The combination of those systems have to fall within these high-level requirements. Mm-hmm. And then people can go off and develop their own systems and see which ones are best, right? We have this sort of competition going on.
I see.
Because everybody has different ideas, and it's going to be really difficult for us to narrow in on one particular approach. So I would put it as here's the high-level requirements. Mm-hmm. Let people go away and develop their own systems. Mm-hmm. And see which are the best ones.
Okay. So let's say defining the higher level specs. I think that's very easy to define, because we only need from the fisheye material an event with the coordinates, the vector, and a probability. Let's say with 85% that's a bird, kind of. That's, from my point of view, that's the task of the AllSkyCam software and the fish mm-hmm. on the fisheye material.
So it's got to be slightly more than that, because you want to know that it's interesting, right? And interesting means it's doing something interesting. It's moving, basically, right? You're not interested in objects that are stationary, for example. A stationary object would match some of those requirements, right? So you need to say, sure. A, is it moving? And B, what do you think it is based on the things that you know? Now, I'm not entirely convinced that we need that second one. I would be more, I think that's more suited to the PTZ.
Yeah.
Right? I think that classification of is it a bird, is it a plane, is much better job for the PTZ because it's going to have much higher resolution.
Yeah.
No,
I
I
agree.
I mean PTZ nothing to have the let me say it a good way. The PTZ just need command from the main box. What to do?
Mhm.
You know what I'm saying?
Yes.
So the PTZ nothing have to do with whatever main box.
Yeah. But
Actually, Fisheye and AI decide. Okay, PTZ, move it. You know, and
Right.
Yeah.
And once
PTZ have nothing to do. Our goal is PTZ to listen command from the bottom
Yep.
bottom box to
Yep.
go and focus. Nothing else, right?
So a control program would say PTZ, go to this
Go to
direction
this
and
coordinate.
get this photograph.
Yeah.
You know,
Right. Get this
just
straight.
But
you know.
Boyan,
So
Exactly.
PTZ
Boyan,
nothing have to do. Yes.
there's an issue here because the material that you get from a fisheye is never a single event. You always have multiple events. And that's the crucial point. We only have one scope that we can turn to. So if you have 20 events at the same time, you have to decide which event you're going to steer your scope to. To be able to do
But
that decision making, we need something like an identifier. It could be a bird, it could be a plane. Either it's based on
So
optical, like machine learning networks that do it
that's
on
that's
images.
what I'm talking about, Richard. That's what I'm talking
Yeah,
about.
okay, Boyan.
PTZ had
Okay, Boyan, we know this. I just having a discussion with Paul about, let's say, the system specs and what the system shall do. And yes, Paul, you're right. The good pictures come from the PT set. And the fisheye is nothing more than a generator of events where the PT set shall be turned to. But still, we have this issue that we have multiple events, and still we have to find a way to prioritize things there.
So I'm not.
Sorry,
I'm
can
not
I say
so
something?
worried.
Pardon me. Who is talking? Who is talking?
Yeah, Yannick.
Yannick.
Just
It would be much easier if you all have your videos on and raise your hands. Otherwise, I cannot coordinate
okay.
this.
Sorry.
Go ahead.
Yeah. Just one thought. Does it make sense to tap into a flight data API so you can pre-check basically?
That's a secondary way. Yes. First of all, we have to detect from the plain sky where you still don't know whether it's a drone or a plane or a bird. If you know it's a bird, then checked. If you know it's a drone, that's checked. If you know it's a plane, then you can correlate with the ADSB or other server data, or use your own ADSB antenna and record yourself, and then correlate whether it's something that is checked. The question is what remains afterwards if all is checked, you know? And still, it can be multiple events, although it is all.
Yeah, it's okay. I think you can exclude planes. Just so if you have a bounding box, you could basically tap into this API and check if it's a plane. You don't need to track it if it is. But of course, there still remains birds and drones and so on. So that's just one thing, but it could simplify the problem a little bit, I guess.
Yeah, certainly secondary. Paul.
Same with satellites. Maybe you could tap into
Yeah,
satellite
absolutely.
API and check.
Absolutely, but this is secondary. Primary is certainly software on the Fisheye material. Paul.
Right. So I think that part of it is actually not too challenging. That if you've got multiple objects and you're tracking and you're trying to decide which is the most interesting one to send to the PTZ, that part of it is not. You could use something like Lionel was suggesting, and sort of the vector and the distance that this thing has moved, and you could figure out whether it's interesting movement from some relatively simple data, and say, and even when we're doing the background detection, it's relatively rare that we hit 20 tracks. And the machine learning stuff usually picks up sort of two, maybe two, but mostly it's one. So the multi-object tracking is not as much of a problem for prioritization as I think you're concerned it might be.
I'm concerned.
Hey, Paul, I have a question for you, Paul. We need to take the good picture or good video about strange object, right? This is our goal.
Okay.
So why we talking about multiple objects?
Bojan, again, we have one scope and we have a fisheye. And the fisheye has the hemisphere, and there can be, let's say, 5 events at the same time.
Yes.
At a certain point, we only know that that is an event. We do not know whether it's a bird, a plane, a drone, or whatever, or a UAP. So if you have 5 events at the same time, but you do not know where to steer your scope to, you cannot steer them to everyone. It's impossible. So we have to have this kind of identification on the fisheye material.
So
and
this
Paul,
is
I have to say,
this is up to AI to decide.
Yeah, genau. Paul, I'm concerned here. I'm not sure whether you can say that in, let's say, in most times, let's say 80%, it's only one event. I don't see that.
90%.
From the material that I'm having, Mike is having, there's always multiples. I mean, there are, of course, sometimes only one jet flying. Yeah, go ahead, Paul, Mike.
I think this is kind of part of the set of requirements that Paul was maybe referring to. Is currently we kind of have a limit where we are able to track. We can track 10 things in one go. That is our configured upper limit right now. But that's just something that I think we've decided and included just purely because tracking is the most compute intensive thing that we can currently do. So I think at some point we need to decide, right, okay, so how many, what is the upper limit of objects we should be able to track? Because you understand what I mean? So that should be some sort of, we probably need to agree on that at some point.
So if you frame the problem in terms of accuracy, recall, and precision, and you attain a high accuracy and recall, the problem of multiple objects is drastically reduced because you're not dealing with false positives in as much as we are, for example, with the background subtraction. Now, what we're actually dealing with is 2 components. One is the detector, and one is the tracker, right? And the detector is the thing that says, hey, there's something interesting here. Consider this for tracking, right? And the background subtraction that we're using, that, for example, Mike's using with the videos to process, is really bad at discerning things like clouds, right? So it produces a whole ton of possible objects that it feeds into the tracker. And then the tracker, we have an upper limit on the tracker so that we don't overload the processing. But the tracker just says, okay, well, all right, now in order to determine whether it's interesting, I need to track these 10 objects that this thing has given me. And if one of them starts moving away from its origin, I'll decide that that is an interesting one, and that then it will become a live track. Okay? Whereas with the machine learning stuff, the idea is that because it's based on machine learning, it's much better at that original detection. Okay, so the number of objects that's going into the tracker is much less.
Yeah.
And I just think that once we have good tracks, we're going to be able to determine which is the higher priority just based on some relatively simple things. Now, is that another machine learning algorithm? Maybe. I don't know whether we'd be able to achieve that within the parameters of the requirements, which is a high frame rate and good accuracy.
Mm-hmm. Okay. Alex?
Excuse me, I have a question, but it may be a little bit silly.
No
So
question.
can we use some other data sets, maybe public, and train our model on it, and then it will detect maybe it's a bird or it's a plane or it's important object?
No, this is not
Or it's
possible. We were looking for
okay.
publicly available databases, and yes, you get birds and planes, but you get them in good resolution. There's a very high signal-to-noise ratio, whereas in the fisheye material, it's the other way around. The fisheye material, you can consider, you see the sky, and you see only one, let's say, 4 pixels moving. So
Okay, I get
that's
it.
the issue.
We have lower quality.
Yeah, much, much, much lower quality.
Okay, I get it. Thank you.
Yeah. And that's the crucial point we are talking here, because yes, Paul, I get your idea. Your idea is not to use a motion detection. Just take the video stream as it is, throw it into a neural network, and let itself learn what it sees, what is there. But my point is, this material is of high resolution, and the neural network to be able to process that would be very processor demanding, wouldn't it? So you would have to downscale the material. But when you downscale the material, you lose information. You know what I mean?
Yeah, so I'm not saying no to your idea. I think it's an interesting idea. And in fact, we do have a single object tracking mode for the simple tracker. And what that does is takes the bounding box and just has that frame in the video. So you just get it. It's like a zoomed in track.
Yeah.
So this is stationary. You just have the object in, and wherever the object moves, the frame moves as well, right? So you could take that and feed that into a classifier.
Mm-hmm.
I guess the only concern there would be, processing power again. So, but does that overcome the delta between out of that system? Would you get the same as machine learning one? I honestly don't know.
So you want us to go 2 routes. One is the route that is using the neural network pure on the raw material on the raw stream, and let it run and learn and teach.
Yeah.
And the other thing is, let's say we have another strategy where we use Mike's approach with motion detection and extract small subframes and create another neural network that is only, let's say, a quick identifier. So would that be two paths that we can approach? Is this your idea, that we go 2 paths?
Yeah, and so this is such a hard problem. I think no one in the world has achieved this, right? As far as I know, there's nothing out there in cutting edge research that achieves anything like this. So the notion that we're going to solve this in a short period of time with people that are not particularly experts in this area is optimistic. I'm always up for a challenge, but this is a really difficult one. And it's not just one machine learning. When you say it's the background subtraction plus a classifier versus the machine learning algorithm, there's a whole ton of machine learning algorithms, and I don't know which one is the best. All I can do is look at the one which I think it's best and try it and see if it works. So I think we need a lot more people to attack this in parallel with all of their own ideas, but the foundation of that is the high-level requirements, and the high-level requirements are to find interesting tracks to pass off to the PTZ within certain parameters of accuracy, recall, and frame rate.
Right. So can I make a suggestion to you guys? One would be, Paul, you have access to the material. You could actually go the route that you already started doing. And let's do Mike, and maybe Mike with Lionel do another route. Would you guys like to do that, or you want to work together, or you want to separate yourself from everyone? Mike.
So what I would probably say there is, I'm busy processing the videos and trying to find good videos or distinguish good videos from bad videos and stuff like that. Once I have a list of videos which have got interesting objects that we have tracked in them, we can then put together a library of interesting videos with objects in them. And I think, so the point I'm trying to make is, it's quite a laborious and time-consuming task working through these videos. It's a ball ache, basically, and it would be best if one of us do it versus everyone. Yeah. I mean, if you guys want to kind of look at the videos and all that, knock yourselves out. I mean, I got no, that I'm not saying you mustn't do it. All I'm trying to say is that it is time consuming. There's better things to do with your time than to like try and work through these videos. So I mean, I'm in the process of working through them now anyway. So once I'm done, I'll put together a list of videos that, from my view, had things that were being tracked in them, and then at least we can have a subset of those videos that we can share with everyone to then pursue their ideas. But I yeah, that's all I basically wanted to say. Is,
yeah, I think that's right. I think what we do is create that set of, hey, here's the things that we want to train on. This is the ground truth, and here's the results of the best algorithms at the moment, right? And the chance of getting the background subtraction to a place where we can run it on the fisheye is probably highest, right? That's probably the least risk. But I also think that's going to be the least accurate.
Okay. So one question to Lionel. Lionel, can you read me? Are you there, Lionel?
I can hear you.
Excuse me. Are you there, Lionel?
I can hear you, Lionel.
Okay, he can hear me. I cannot hear him. Interesting. Okay, guys, I'm stepping out and stepping back in.
Yeah.
On the computer then.
Now I see you again. Okay. There's something weird here in Discord. Sometimes I really lose connection to some people. Okay. Question to you, Lionel. The material that Mike is creating with his algorithm contains bounding boxes.
Yeah.
Yeah. Would it be an idea that you take this information, which is stored in files, in JSON files, as I see, and excerpt smaller images from the material, so only the bounding box images, let's say, and then use this small images and let a neural network run on it. I think in that case you can even use existing neural networks.
No, well, that's not that's not the way I went.
Okay.
I only consider I don't consider what's inside the bounded box. I consider the bounded box itself. So its shape, area, speed, distance traveled.
Okay.
And what I wanted to add, which I think is important, is that if it's a simple k-means classifier on all those parameters, then there's no need to have a human look at the tracks. We'll reach a point where we have a number of clusters which the tracks are assigned to, and then we can actually look at one or two tracks to say, okay, this class is an airplane, this class is a bird, but there's no need to go through every single one to teach the model which is what. So it's the way I went was unsupervised learning.
So
and also about the multiple object tracking. In the cluster assignment, there's a degree of confidence. So it means, okay, the classifier is 90% sure that this is a bird, and it could be, it also has a 10% chance to be a plane. So it's not black and white, and I think that info can be useful when we have multiple tracks. So we would have tracks that can be safely ignored because we have some degree of confidence that it's a known object, and then we have the unknown class. And so the unknown class should always take precedence.
Yeah, I think that's great. And I think that's pretty much what Richard is saying. It's just you're using the k-means instead of the deep learning stuff. So yeah, I think that's great stuff.
I mean, I'm sorry. Can I say?
Yeah, of course. Go ahead.
I'm putting together like a list of bloopers. I don't know if that's the right term as well. Just so that you can see some of the things, because there'll be things that you might not even have considered, you know. And I can show you a couple now if you. I don't know if I can share. If you want me to share my screen,
well, why not?
And show you guys. But I've got one of the folders. One of the sets of videos I've processed. I've got a couple of bloopers. You guys interested to see?
Yeah, of
or
course. Share.
Is this good enough to show you? Or interested at all, or not really?
Je retire la vidéo.
Okay, so just give me 2 minutes here. So. Yeah, so
I'm going to grab a coffee, but I can hear you guys.
So these are some files. I've just got to kind of get this figured out because I've now pinned it to this folder, but it's not going to be the video. So just give me a minute to try and figure it out. I'm assuming you're not seeing the video with the. So let me just. Yeah, no, you're not. Okay, so sorry, just give me a minute. Let me just try and.
No worries. Take your time.
How do I? Okay, so you guys can you guys see this?
Yes.
So it's like a little spider sort of thing. So that's kind of one of the challenges. Let me see if I can just give minutes. Yeah, so that was a really quick run through of some like challenges. I don't
How
know
come the box is so small around the spider? How come the box doesn't surround the entire spider?
Yeah, I'm not entirely sure. In all fairness, I haven't kind of. So it is on my list to try and debug it and try and kind of look into it a bit more detail as to why it's why it's
I'd
not
say
picking up
that one. Yeah, I'd say that one's probably due to the background subtraction, right? If you've got like a large object and you're moving, the background subtraction is only going to notice the edges. So it's going to say, oh, there's something here and there's something here at the front and the back if it's moving this way, sort of thing. Whereas as a human, we see it and we're like, oh, it's the whole object that's moving. But background subtraction doesn't see that; it just sees pixel movements.
Yeah, that's fair enough. But yeah, so I just thought it was quite interesting when I was looking at those. So I just thought I'd kind of show it to you guys, really.
Mm-hmm. Cool.
That's pretty much it. To be fair.
Okay. So guys, yeah, Paul, you wanted to say something?
Yeah, so at the risk of derailing everything.
Yeah.
Trying to get interest in this project, I think, is quite important. One of the things that I've been interested in, I've been researching some Web3 stuff as well, and whether we could turn this into something like a DAO that owns the material, right, and use that to raise funds to pay people, or just to get a bunch of interest in this, right? So the DAO, if you said every interesting track that we found was minted on the network, and then the DAO owns that network, right? So they own the rights to it.
What is a DAO?
It's a organization that's backed by like a cryptocurrency. So it's a distributed organization that's backed by cryptocurrency.
Okay.
And you say everybody could own a part of that DAO. Now, typically DAOs are used for decision making in an organization, right? So everybody has a certain number of tokens and they use it to vote on what the organization should do. But you can also have the DAO owning property in the sense of an NFT. Now, the material that we generate could be an NFT in this scenario and be owned by the DAO. And the hope is that, hey, at one point, we discover something that is really interesting, and that thing is owned by the DAO, right? It's open to everyone, so everyone can see it, but the rights are owned by that DAO, and everyone has fractional ownership in the DAO who's invested in it in some way, right? So we could,
It's Tommy's world.
Hi, Tommy.
You're dead on, man. You're dead on. Keep going.
All right.
Paul, yeah, you are an interesting path. I'd say we shall take our time and meet somewhere in the next days and talk about this issue. Tommy, I think you want to join us there because you've got some ideas too. It is about financing development. That's what your intention was, Paul, right?
So, not necessarily gaining interest, right? Because people will work for free because if you pay them in the tokens from the DAO. It's like, oh, we'll give you 100 tokens a month or we'll give you per line. I don't know.
Yeah.
You find some remuneration to pay them. So they have fractional ownership in this organization, which then owns all of the data coming out of it. Right? And people who generate the organization, people who run their platforms, they get ownership in this as well.
It's a co-op.
So we have this whole. So there's an incentive for everyone to do things that benefit the project, because in the end, if we do discover something, then the value of those tokens goes up, right? And everyone wins.
Is the DAO like a cooperative?
Yeah, kind of.
Okay.
It's essentially like a corporation, but all of the shares are tracked on a blockchain.
Okay, good point, Paul. I'd say we stay in touch, and we should make a meeting in the next couple of days. I think Chris Lito, who also wants to generate NFTs to finance parts of Sky360, could also be part of that, because we all join the same ideas somehow. I think it's good if we put this together on the table and discuss this.
We need a crypto channel.
Yeah, crypto channel. Oh dear.
Crypto channel.
A crypto channel. Yes, we need something like this. Okay. Anything else on the subject of on the machine learning side? Anyone who wants to contribute anything here yet? Otherwise, we step over to, let's say, something on the user interface. Rebecca, are you there? Rebecca?
Yes, I'm here.
Ah, here
Can
she
you hear
is.
me?
Yes. So my question to you. Okay, last question, guys. Anything about the machine learning you want to contribute? If not, we head over. Okay. So Rebecca, you were so gracious to post something in our Signal group, developer Signal group. We had not time yet to review it. Can you, in short, summarize what the paper is?
Yeah, sure.
Okay.
So when I was assigned the task of making the GUI, I needed to, see what was going to be displayed on the GUI, and with that information, and find out where that information comes from and how to access that information. So there were, many different aspects that needed to be added to the GUI. So what I did was use that design doc to sort of organize everything and not get off track. And that way, for any other new people that want to join, they can go ahead and take a look at that as well. So, I'm sorry, I can hear someone in the background. It's distracting. So I went ahead and broke down everything into different aspects of the GUI. For example, where you display the GPS data, you view the station ID, times, the sensor status, and as well as weather events, real-time air traffic. And I broke that down further into finding out exactly how am I going to get that information.
Mm-hmm.
And so that's where some of it will come from, APIs that you can access via the internet. And some of that comes from the hardware. I'm not a hardware person, so I don't know exactly how that's going to be provided to me, but I did put down in the design doc sort of what we'll need in order to access that information for the GUI and display the results and that information on the GUI. Yeah. And I took a look at, I think it was UAP Paul's live tracker, his YouTube thing. So I noticed that you did have something similar to that. And I think that was more of a software program that you had built previously. Yep. But maybe some of that information, it will be the same that could be used for the GUI. Also, the GUI, there's two types. There's the PyQt6 or the Django GUI. So it looks like the Django GUI is the better option, I would think, but that's up to everybody there. And I wrote down some of the pros and cons on that as well. Mostly it has to do with the VLC player. But if I'm right, you may be actually live streaming the video on a separate device instead of through the GUI. Is that right?
Can you repeat the last sentence?
Yeah. So for the live stream video, are you going to actually be putting that on a separate device rather than through the GUI?
A separate device rather than the GUI. Where do you see the difference there? Why do you see a difference? Can you explain?
Sure. What I heard earlier in this meeting, it looked like you were going to live stream. You were going to live stream the video directly through the Raspberry Pi.
No, no. The Raspberry Pi idea was another idea how to increase the buffer for the Nano, because Christian saw that he had an issue with the buffer overflows. So when a 12 megapixel video stream or 16K video stream comes in, the Nano couldn't handle it. So that's why the Pi comes into play. But it's just an intermediate thing for increasing the buffer. No, it's there's not. I mean, we can if you say it is needed that there is a dedicated platform hardware-wise that acts as I don't know, a web service, for example, that you need for the GUI to attach to and represent the data that is generated there. Is that what you mean? A dedicated platform?
Well, that's what I thought they were doing, but if they're not, then just forget that. Just forget that.
Okay.
No. Let me take that part.
Yeah.
It's a very interesting idea that, and I thought of it that we could split the feed and give it from the Pi to the GUI directly. Yeah, we can do that, and it's a good option not to disturb the Nano anymore.
Mm-hmm.
But we have to think about it, whether we can do it like this, because the Pi can handle web services quite well. Because there are people in the music business that are using Pis, especially with 4 and 8 gigabytes as music and video streamers. And I think, yeah, we could do it like that.
Do we need it though?
If we want to provide a web-based GUI for streaming, so the people can look into, yeah, we need it.
Sorry, can someone give me an overview of where we are in the UI stuff? So
at the very beginning.
That's kind of my day job. So, and I've done Django development back in the day. But if someone can give me an idea of what UIs we're thinking of running where, there's a application in the cloud, there's an application running on the Pi 4, or these are the options, right? Somebody give me an overview.
You know what? This is a mess, quite mess. We have Jetson Nano, then we have Teeny, and then we on top of that we have PI, and this is quite a mess.
Yeah, we have several
but
systems.
This mess comes from the shortage of supplies. If we would have had Nanos or HGX available to a moderate price, then we wouldn't have to look for a solution to increase the video buffer.
You know what?
Do things elsewise.
Christian, we have so much mess, so much platforms, PI, Jetson, Teenies, and whatever. I mean, why are we doing that?
It's a multi-sensory. It's a multi-sensory platform, and I think it's quite normal for a multi-sensory platform to have multiple boards and multiple devices. I don't see an issue here. Coming back to your Bojan, we can talk about this later. I don't think that changes anything at the moment, right now. Paul, I want to answer your question. First of all, we need something for the end user to be able to know what the station is doing at the moment. So we need a user interface that attaches to the station he's owning, only his station, not the other stations of other owners, and gets a kind of a live view overlaid with additional data of events. So it could be a live view. Sorry, I mixed things up here. It could be a live view, but it could also be an event view of historic events. always overlaid with the data that was recorded at that time. And a third view in that part would be to have a kind of a development view. So to be able to see deeper into the system, temperature-wise, performance-wise, whatever have you. But this is let's say the bundle of the station with a user interface. There can be a web service, but you have to be in the same network. And the other thing is, and this is not even a topic at the moment, is that when the data is in the cloud, that there has to be cloud services and the front end as well. But we skip that part because we want to focus on developing the system as is for this year. So it's actually the cloud service and all this thing that is going along this is actually postponed for a year, not for this year. I think we have a lot of things to do, and 1 year is not much. So, did that answer your question?
So it does. The only thing I'd consider here is, does it really simplify things if we put everything in the cloud to start with, and only have, so if you had essentially an API running on the edge, and then you pipe everything that's interesting, not the video, everything that's interesting, the metadata, into the cloud, and then you have one area where people can go to do everything. And then when you want to get the data, you either have a mechanism for going local to get the raw stuff, or you upload interesting events that can be viewed at a later time. I feel that approach may just simplify a lot of things, especially if you're going to go there in the end anyway.
You think of usability for the end user?
Yeah, sorry.
I interpret what you say with a focus on the end user, right?
Yes. So that would be like the.
But it has backdraws, and one huge backdraw is that not every station is always on. Meaning that you have situations where data is only taken off a station a month later. Let's say people have it in I don't know, I wouldn't say in the desert, but there are people in our community that say, I'm living very far away from the city. I don't have network every now and then, and I can only take, let's say, an SD card or make a copy from what is stored on the local disk and copy it then and then bring it somehow in a cloud. So this is one issue, not being always on. There can be 1,000 reasons why this is, but not always on is one issue. And the second is that if we start creating this cloud service, it would involve that we have to create a new team for this, new people to work on this, which is actually not a problem, but an issue because it creates expenses. We have to pay for that cloud service, like you do for the AWS cloud. We did this with SkyHub. We had a cloud service on Google Cloud, and there were also people working with, let's say, setting up. It wasn't really working with, but more like configuring, setting up Kibana and what have you, what is necessary there. But it created license fees and costs, so we ended up, I would say, around $400 per month. And that was for an NGO where we just created almost $400 per month. It was burned in the second. And that's something where we need more elasticity, and that's why we postponed all this cloud service thing because of costs into the future.
Right. So I think the way I design it is you build the application and you can deploy it anywhere. You can deploy it in the cloud, or you could deploy it to a local Pi server. For the people that wanted local access, they'd have to buy a Pi server and install it on the Pi server. For everyone else, they wouldn't need the Pi server. They'd just go straight to the internet. Right? So you simplify the majority of installations because you don't have that additional component. And then you're only building one system. Now, the cost is a valid point, right? I won't tell you how much we spend on server costs a month.
Yeah.
It's insane.
Yeah.
If we create NFT, it'll pay for it.
There you go.
Yeah, but this is
And
future.
$400 a month is a tiny, tiny, tiny amount of money in this business.
True, but we have to face the reality, and we are, let's say, just the ones here in this channel that are the developers, and then we have 1,000 people in the community. That's all, and we have some patrons,
Right.
you know. And there's also one issue. I had funding in my life. I don't want to go that route again.
So that's why the NFT with our route is interesting.
Yeah. To be independent from banks as much as possible is the way to go.
Right.
Decentralized, baby. That's what we're all trying to do.
But we're not there yet. So we first have to establish that. I do not want to go a route where...
I'm doing well. Don't worry.
I have one question. Is there any chance that there could be some like account licensing costs that would offset these cloud fees?
Yeah.
Maybe if the user wants some upgraded set of features, then it's, you know, $13 a month or something.
Yeah. We were thinking about this when, let's say, a year ago with SkyHub, where we had these issues with the financial part, where we said, okay, we do a kind of a club and the membership fee, so everyone who has a station shall be member, and that's why he pays something. So this was a long discussion. I can give you some arguments for this. One is, first of all, we are more interested in the data than in receiving the money. That sounds weird, but it is. The data is much, much more important than the money. Meaning, if someone says, nah, $13 per month is too much for me. I invest money. I invest $1,000 in my setup,
Sorry,
in my box.
What I actually meant was it would be free to everyone, but maybe there is some set of features that would be additional that could cost money. So you get all of the data, everyone can join for free, but maybe there are some features that have more cloud compute requirements, and those are the ones that you would pay for.
That could certainly be an idea, but I would postpone it into the future, because we first have to have that cloud solution and the financial part of that cloud solution until we go that route. So I'd say we shall postpone it to next year, such questions.
Yeah, maybe the cloud part is the automated part. So the end user can have the free copy. Here you go, do your own thing. But the cloud part would have more GUI interface.
Yeah, could be. It could be because cloud services generate costs that we compensate those costs at the point where they are created, of course, yeah. And for now, the station and Sky 360 and the software and hardware, what we all of you are developing is a contribution for us to, let's say, a higher idea. And just because of that, it should be open source and available for everyone. And also the data that's generated out of that should be open source and available to everyone. And we want to keep it that way, not derail of that.
Yeah.
Yeah, so...
Who is?
Mike. I still have a... Hi, Richard, sorry. I still think... Sorry, I didn't put my camera on.
Yeah.
So I still think there should be a consideration for monetizing the data, especially if we are able to find, if we capture something, to be able to license and monetize the data, in one way or another, just so that it feeds back into the project. I'm not saying we must do it. All I'm saying is maybe just a consideration.
That's
Yeah, because everybody once you capture something, then everybody's going to want to have access to it. And why not go public with it, right? Why not license it and make the money off of it?
Yeah, that's a dangerous route.
But then maybe some people will come and say, oh, they are faking something to make
exactly,
money.
Exactly. That's the point.
Yeah.
Exactly.
It's not really our mission to make money. Sorry.
Money making is always
Right.
dangerous.
With an NFT, you can have it public, right? So everybody can view it. It's just the ownership is retained.
Yeah, but
which would be acceptable.
The data itself should be open source and available to everyone.
Yes.
That's our primary goal. Sorry, guys, and if you don't like it, please debate me. But I actually don't want to derail from that. That's our main purpose. What we are doing. That's why we contribute our time and even private money, so that this world really gets awake from the situation, because the populace is asleep. There's only some people who are in the know, and they don't share their information. And that's why we do what we do. We do a citizen science, we do a grassroots thing, and we do it for us. I mean, if we start today making money with the data we create, next thing is, Tommy, you want to see the data? You have to pay for it. And Tommy says, hey, I contributed so much, why should I?
No. I'm saying I'm saying like
you know, I'm joking here, okay?
Yeah, I think we might be thinking about this slightly differently, but yeah, I take your point though. It's a discussion for another time.
Yeah.
There are organizations. We can talk another time too. What I want to say is there are other organizations who created data and put it behind a paywall, and they were very much offended by
That's not what I'm
community.
referring to.
That's not what we want.
No.
Yeah. No, that's not what I'm referring to.
So
but
guys,
that's good. We can talk later.
Yeah. So guys, first of all, I'll make we stay in chat for discussion when we meet about the NFT idea. Paul, I summarize it as the NFT idea. So we make an appointment somewhere in the near future, all right? And for second, I'm stopping now recording.